My name is Daniel. I work for Condignum as a senior security architect here in Vienna. And my main task is actually to kind of help our customers with their day-to-day security challenges, either by applying our Condignum security platform or via personal security consulting. And I'm also a lecturer at the University of Applied Sciences in St. Pölten for web and application security. So let's start right into it. If we look back in time, the last 20 years, roughly, then the classical network applications in big enterprises were rich clients. So we had some kind of exe file, which was started on a computer. And it contained most or a lot of business logic and also the presentation of data. It was connected to some kind of backend, and which had also business logic in it, and they communicated via RPC calls most of the time. And there were different protocols for that, like T3 or Corba. And of course, they had some kind of database, and sometimes they communicated with some other backend service via XML, or there were different stuff around this time. Almost at the same time, the traditional multi-page web applications evolved or became more prominent, and they were actually designed as thin clients most of the time. So we replaced the rich client with a browser and had some minimalistic web page in it with mainly HTML and CSS and a little bit of JavaScript. So it was mainly for presentation of the data, and all the business logic was located on the server. And we talked with HTTP or maybe HTTPS sometimes. And again, they had some kind of database and some kind of other backend connection. And in the last few years, there was actually a shift to the so-called single page applications, which are actually, again, a rich client. So we have heavy HTML5 and JavaScript frameworks, which contain, again, a lot of business logic next to the presentation. And we also have mobile apps, which are very common at the moment. And those communicate with a backend via HTTP and now REST and JSON calls. So we have APIs in the backend. And those, of course, again, talk with some database and some other backend services via REST and JSON. So we actually have kind of evolution from rich clients to server applications, and then again, rich clients with APIs now. And if we look at the typical vulnerabilities for each category, in the beginning, there were a lot of authentication and authorization bypasses because it was very tempting to implement security features in the front end on the client side, because there were rich clients, so we had logic in there. Why not just checking the authorization there? Seemed like a good idea. Had some problems because everything I do on the client, the attacker can just disable it, circumvent it. It doesn't really matter for security actually. We also had a lot of backend injections, like SQL injections. They were very common at this time. And we had clear text communication most of the time because all these RPC calls, they were almost never encrypted or something. So they were completely unprotected. And we also had a big problem with insecure deserialization because the RPC calls worked in a way that objects from the client were serialized, transferred, and then deserialized at the server. And combined with the insecure connection, this was pretty bad actually. So you could just manipulate the data stream, and when the data stream got deserialized on the server side, all kind of things could happen there. And of course, a lot more, but those were like the major big vulnerabilities. In the traditional web apps, the thin clients, so the multi-page web apps, we replaced the exe files with browsers. And because of that, some typical web vulnerabilities came into the mix, like cross-site scripting. We will talk about that later. and a thing which is called cross-site request forgery and click checking and a few other minor things. So now it's the big question. Is the modern single page applications, are they the best of both worlds or a combination of all the possible vulnerabilities? And I think you can guess where I want to go with that. If we have a look at the top 10 list of nowadays vulnerabilities from the Open Web Application Security Project, the OWASP, they publish a top 10 list every couple of years. And currently, it's those 10. And if we have a look at which of those were already in the slides before, it will be half of them. And it will be exactly those 6, because nowadays the backend injections and cross-site scripting is one category, the injections. So actually, almost all of them are in the today's top 10 list of vulnerabilities still. For the sake of time, we will just have a look at the first 3, because we don't want to spend the whole night here. So we'll just focus on the most important ones, which are broken access control, cryptographic failures, and injections. So the first one, broken access control. It actually means, okay, somebody is able to do something he or she is not allowed or supposed to do. For example, to perform a specific action or to access specific data, for example. It is currently at the number 1, and it gains popularity again because a few years ago it was on place 5. And if we look back in time, in the beginning it was very prominent, then it decreased a little bit, and now it got up again till number 1. And if we compare it with the top 10 list from the for APIs, so there's a specific top 10 vulnerability list for modern APIs, there are actually 4 entries which all lead to broken access control. So especially in new technologies, this is again a very huge problem. How come? We said before, for rich clients, it was very tempting to implement security checks in the front end. And we had this problem with the insecure deserialization. Then, in the meantime, with the traditional web apps, those things were not such a big of a problem. They were too, but not that big. The most challenging part was to kind of protect all the URLs and objects and yeah, in the resources in the backend. But now, again, we have a rich client again. So it's, again, very tempting to do some checks just in the front end. We, again, have insecure deserialization, because if you exchange data with, from a browser to a server via JSON, you can, for example, in Python or Java, just take JSON data and convert it to an object. So we have the same or similar serialization problems again, which we had in former times. And there are some additional problems which are caused by the whole API paradigm. Like, for example, we now use all the different HTTP methods, which was not the case earlier. We just used get and post most of the time here. Now we use all of them. So the attack surface is broad. We have sometimes cross-origin access, which wasn't a thing 10 years ago. It's quite new, actually. And sometimes we have things like direct data store access to some S3 buckets and stuff like that, which is, I mean, if I think about it, sometimes this happened here also, but those were really the really bad applications. So what do we have to do to get access control right? First of all, we have to stick to some very basic security principles. They are actually from the 70s, from Salzer and Schroeder. There are 8 of them, but 3 are important for access control, which is the least privilege principle. It's a little bit small, sorry. The least privilege principle, which just means if every user and every program just the privileges they really need to do their job and not more. Fail-safe defaults, or also called deny by default sometimes. So always make sure to base your decisions on explicit permissions and not on exclusions. So allow lists instead of block lists. If you imagine, for example, a firewall rule set, you always say drop everything and just allow a few specific legitimate connections. And this should be the pattern for every decision in access control. And complete mediation, which basically just says every access to everything must be checked. So every allowed HTTP method, if you, for example, have a function in your application, then always define which HTTP methods are allowed to call this function. Every function and URL and every resource which gets accessed have to be checked again. So here's an example from the Spring framework. You can use annotations, for example, which allow you to check, okay, is the user which calls this function, does he have admin permissions for the contact object which is processed here? There are a lot of different frameworks and possibilities to really fine-grainedly check authorization. Always do it on the server side. So as we said before, security checks on the client side are actually, they are not useless because they can be good for usability. So your user gets faster feedback maybe or something like that. For this, it's good, but it has no security impact because an attacker can just disable it. And also try to centralize all your authorization decisions. So either in your code via, for example, just try to encapsulate it in an own module, or you can also create a dedicated authorization service, which you call for the authorization decisions. And if you're interested in that, I can recommend you the Open Policy Agent, which is a framework that helps you build a pattern like that. And the last one, it's very recommended to use data transfer objects. So it's like every time your application communicates with the outside, so with the client or some other service, you don't use the original objects, but you use a dedicated object just for data transfer. So in this example, you have an object user with name and password, and then object role with a name. But you don't want to leak the password outside, never. So you create a data transfer object, which just has the attributes you want to share with the client or the other service, and you have a mapper in between. And this helps you to ensure that the confidential data is never going to leak outside. Any questions to those points? Okay, cool. So this will be my recommendation set, best practices for access control. The second one, cryptographic failures. If we have a look back for the last 20 years, we can see it was always there. It was named differently sometimes, but it was always there, and it was always like somewhere in the middle. And it still is, or at the moment it's becoming a little bit more prominent because just cryptography gets more common and is used more often. And so of course, more mistakes are made. So what are the best practices for crypto usage? Really in a brief nutshell, because cryptography is a whole topic for a whole evening on its own. But we want to properly protect our data in transit and also at rest. So in transit, actually just use HTTPS, because nowadays it's pretty easy because you only need a certificate from a trusted certification authority. You can just buy one from one of the big CAs, or you can just use Let's Encrypt, where you can get free certificates. They are, it's actually a very great service. It can be automated, so you can renew the certificates in an automated way. Very easy, actually. Then you need a secure configuration, and Mozilla is your best friend here, because with this configuration tool, Hope it works. To open it here. Yeah. You can just select your server software. You can select how backwards compatible your configuration should be. Let's say modern here, and then you get a best practice configuration for your server, and you can just copy paste that, and you actually have the best practices implemented. And then you can think about enforcing HTTPS at your users' browsers via setting the HTTP strict transport security header in your application. So it tells the browser, this domain or this application, please just open it via HTTPS. And if you are really sure that everything works fine with HTTPS on your application, then you can also think about entering your application in the HSTS preload list. Then it gets hard-coded in the browsers, in the main big browsers. And also, if somebody never accessed your page before, already for the first time, the browser will automatically use HTTPS. So if you are safe and you have everything covered with HTTPS, you can just enter it here, and nobody will ever access or try to access your page again with HTTP. And the big question, how do we deal with the connection for our internal services? So in our data center, it's always a big discussion with customers. The big answer in the year 2022 is use TLS also in your data center. It's no luxury anymore. In terms of zero trust, it's the best practice and the recommended best practice nowadays to also encrypt the traffic between your services. And this is mostly done via MTLS, especially if you work on Kubernetes platforms or container platforms. There are so-called service meshes, and they most of them provide an TLS support for you. So it's also not that hard to configure anymore. And as we know, nowadays, a lot of attackers are already inside the network. So just to apply perimeter security is not really considered state-of-the-art and sufficient anymore. Okay, and if we talk about data at rest, so when we store data, then the first thing we have to do is to evaluate the protection requirements of my data, because not every data is critical, right? Sometimes it's just not really important, and then I don't have to spend a lot of money and resources in protecting it. But if my protection requirement evaluation says, oh, this is very critical for you, for your customers, and so on, then I can set the right priorities and can really take care of the data. If I know that, then I have to pick the proper tool for the job that needs to be done. For example, if I want to protect the confidentiality of my data, I need encryption. I need either some asymmetric encryption mechanism, which works with a public-private key pair, or a symmetric encryption algorithm, which works with a shared secret. If I want to protect the integrity of my data, then I need digital signatures or message authentication codes, which are actually hashes with a secret in it. Yeah. And if I want to, or if I have to store passwords, how do we store passwords? Don't, yeah, best answer, yeah. If we have to store passwords, how do we do it? Heavily salted, yeah. There are actually specific functions which are designed for that. You have so-called password hashing functions, or key derivation functions are also good. For example, decrypt, scrypt, pdkdf2, hkdf, and those algorithms or methods, they are designed to be slow as fuck. So if we store a password, we don't want anybody ever to recover the initial password from this hash. So these functions, they apply a lot of iterations, a big salt, different hashing functions to this one password. So it gets really, really slow and hard to crack it. So if you really need to store passwords, use one of those and you should be fine. And like every time when we do something with cryptography, really pay attention to the key management, because this is most of the time the weakest link. And there is no shame in getting an expert for that, because it's a whole science for its own, actually. Any questions to the cryptography stuff? Okay. Then already the last one, but this is also the biggest one, the injections. As I said before, in the current list, there is just one entry, which was in the old top 10 lists. There were 2 entries, which were the backend injections and the cross-site scripting, which is actually kind of a front-end injection. And if we look back, they were always around, and they were always on a quite high rank, actually. So those are really nasty and annoying things, actually. What is the basic problem? Because if we want to tackle a problem like this, we have to deal with the basics. The basic problem is that the user input gets included in a specific context, which messes up the predefined code or query structure. This context can be something in the backend, like SQL or NoSQL, LDAP, XPath, or even OS commands. And let's try to never use OS commands in the applications. That would be the best, because it's, yeah, a lot of things go wrong here. So if you have to use OS commands in your application, be very, very careful and check if there are any APIs in the technology you use which handle them safely, and otherwise do really strong input validation and be really careful. And on the front end, the context can be HTML, JavaScript, CSS, so everything that happens in the browser. And then we talk about cross-site scripting, actually. So what is the basic solution? We want a strict distinction of code and data for the interpreter via context-sensitive output handling. This can be prepared statements, sensitive output encoding, or output sanitization. And I will show you examples to make it more clear. And of course, we don't have to do this by hand. There are a lot of frameworks and libraries which help us with that task. And of course, always additional input validation, which is really important, but it's almost always just a second line of defense, because attackers, they are really creative when it comes to their attack payloads. So this web page here shows you a lot of different types of cross-site scripting. And if you scroll through this site, you can see a lot of different things which you will never be able to filter all of that. If interested, you can have a closer look at this one. Okay, so we said we have backend context and frontend context we can inject it. One of the most famous backend injections is the SQL injection. So how does it look like? In our application, we have a SQL statement like that, which says, give me everything from the taxes table where the name is the current user and the year is the year from the input. If we open this application with the year 2020, then we get the taxes that Luke Skywalker paid in 2020. Everything fine. But if we call it with something like that, I think my pointer doesn't work at the screen, so that. If we use something like this for the year, then the interpreter sees this, and the input here completely messes up the predefined structure of the query, because it now says, give me everything from taxes, from the taxes table where the name is Luke Skywalker and the year is 2020, or 1 = 1, which is always true. So we now achieve to mess up the structure of the query by just entering some bullshit. And then we don't just get all the taxes paid by Luke from all years, but also the taxes paid by Darth Vader, which are incredibly low. So I don't know. How do we prevent it? We can just use prepared statements. This tackles the whole problem at its root, because we can predefine the structure and tell the interpreter, okay, this is the structure, and here will be user input. And it doesn't matter what the user inputs here, it's just text. It is not allowed to modify the structure. Or we can do it even more easy. We can use object relational mapping. Those are frameworks which allow us to map our relational database to our object-oriented code. So we can create classes for our tables, for example, and then just operate with the database like we do with normal objects. So we don't have to write queries on our own, and the framework just creates the prepared statements for us, and it's all fine. Happy world in most cases. Okay, this was the backend side. So a typical example for a backend injection, and they all look kind of the same. So it doesn't matter if it's XPath or something else. It's always the same structure actually. And on the front end side, we talk about cross-site scripting. And in its simplest form, it can look like this. So we have an application, a Flask application, which takes one argument, a name, and just welcomes this user with his name. And if we call this application with the new user Luke, then we welcome Luke. But if we add some JavaScript at the end of the name, the browser gets confused and executes the JavaScript code, because for the browser, he just sees a new structure. So the structure we defined here is completely messed up. The browser sees, or the interpreter of the browser sees, okay, there is JavaScript, I will interpret it. And as an attacker, I would now just paste this link, send it to my victims, they click on the link, and the browser of the victim executes the JavaScript code I put in the link. And of course, I can do way worse things than just firing up an alert box. I can actually, do everything the application could do with JavaScript. In this example here, the payload or the user input gets embedded in the HTML side on the server side, so by a server side function. And this can also happen with a client-side function. So in our client-side code, we can, for example, have a script, JavaScript part, which takes input from the URL or from something else, from via an AJAX call from the backend or from wherever, and puts it in the web page. And the attack would look kind of the same, but it's now the client-side code which embeds it. And then we talk about, then it's called client-side or DOM-based cross-site scripting. So it's just the difference if the server-side application puts the payload in the web page, or if the client-side application puts the payload in the web page. How do we fix it? The old school way, either we do context-sensitive encoding, which is the strictest form. So we just we take all the structure elements like the backticks, all the HTML characters, and exchange them with their encoded versions. And we can do this, for example, for the HTML context with an escape function. Can just tell them, okay, please escape my username input here. And then the browser sees that this is just text. So he doesn't have to interpret any JavaScript. He just puts it out as text, and we're safe. If we don't want to encode or remove all the HTML tags, but just the malicious ones, then we can do sanitization. So, for example, in Python, you can use the Bleach framework and say, please clean my username and strip all the bad stuff. And when we then call this example with something bad and something good, like just a formattation for my username. In this case, Luke wants his username to be italic, then it's fine. The Bleach framework just removes the bad script tags, but leaves the italic tags like they are. So this is, for example, if you implement some kind of what you see is what you get editors where somebody can format their blog posts or something like that, then you need this. And of course, you can also do this not only on the server-side code, but also on the client side. So for example, with the most popular framework or library is DOM Purify. So in our example before, if we have JavaScript code that embeds user input, we can sanitize it with DOM Purify, or which works perfectly fine. Or we can, instead of using unsafe things like inner HTML, or in our example, the right property here, we can just use safe things, which are those here. And you can see this on the cheat sheet series site from OWASP. So if we not just write the input into the page, but we use the safe things. So we say, okay, let's select the greeting element and insert text there. Then the browser does everything fine. It will be encoded and we are safe again. So those are the options, the old school options. And of course, nowadays, most of the time we have some kind of JavaScript framework like Angular or React for our front end. And especially Angular does a really good job because if we use the default output from Angular, it is perfectly fine encoded. So we don't have to care about that actually. And if we use this inner HTML attribute here, it is perfectly fine sanitized. So if you stick to the default options from Angular, you're actually pretty safe. There are some exceptions. So if you're somehow not happy with the default stuff and you want to bypass this, then you can use the bypass security trust something functions or properties from Angular. And then you don't have no protection from the framework because you bypass security. So in this case, you have to take care of your own, for example, with DOM Purify or something like that. And Angular also has some so-called escape hatches. So with some tricks, you can escape the framework, the Angular framework, and operate with the DOM in a native way. And then, of course, you also don't have any protection. It's similar for React. So the default output is also encoded in React when you use it like that, but it's not encoded for URLs. So if you use something like, if you use user input in an href of your links, then this is prone to cross-scripting attacks. It's actually at the moment deprecated, and it will be removed from the Angular framework, from the React framework. But at the moment, this is a little bit dangerous, and you have to take care yourself about it. And React has no own automatic sanitizer like Angular do. So if you need to sanitize input, you have to use dangerously set inner HTML and in combination with, for example, DOM Purify to sanitize the input on your own. And React also has some escape hatches, which if you use them, be really careful because you escape the React framework and you have no protection anymore. Okay, this was like how we can deal with cross-site scripting, first line of defense. Of course, there is also a second line, the content security policy. You can set a content security policy header, an HTTP header, and this restricts resources the application is allowed to load. So if you, for example, set this header here, which is a very strict one, then you are still allowed to load JavaScript files from your own application or your own origin, but the browser doesn't load any external JavaScript files anymore, and the browser also doesn't execute any inline script anymore. So it gets way harder for an attacker to inject JavaScript code to your application. Of course, you can make exceptions. You can have a whitelist, or you can mark one of your JavaScript blocks as a trusted script loader, and this block can load other scripts. But this is, again, a little bit of a science on its own. We can fill a whole evening just talking about good CSPs and how to configure them. So if you need to do this, yeah, just have a very close look of the options and how you design this. And a very nice feature is the reporting feature. So you can define a reporting endpoint, and you can configure that every time somebody tries to violate these restrictions, you get an alert on this reporting endpoint. And you can also say that you just want report only. So nothing will break and nothing will be blocked, but you just get the alerts, which is also quite a nice thing. Okay, and then one last thing, and then I'm finished, is a very new feature, which is called trusted types. And it can actually be activated via the content security policy. And when you activate this feature, then the browser doesn't accept untrusted input from dangerous things. So in our example before, where we got the username parameter and just write it into the web page via document.write. If you enable trusted types, then the browser would just say, what? You want to include insecure input in a dangerous thing? No, that's way too dangerous. It must be a trusted type, otherwise I don't do anything. So the browser really refuses to execute this. How can you make it work? You have to mark your input as trusted, and you can, for example, do this with DOM Purify. So you can say, okay, DOM Purify, sanitize my input, and give back a trusted type object. And then it works, and it's safe. Or you can also set the trusted type policy, for example, a default policy where every time something is written in an unsafe sync, the default policy is called and the input gets, in this case, sanitized with DOM Purify, and you're safe again. Or you can create named policies, and you can explicitly call those named policies if you need different functions. And you can also combine this with Angular or React. So this also works perfectly fine for these frameworks. Sorry. The only disadvantage, it's quite new, and it's just supported by the Chromium engine. So we have Chrome, Edge, and Opera who support it at the moment. But it's not that big of a problem because you can actually just use it in your test and development environments. So if you activate it and then test your application with Chrome, for example, and you don't get any errors and the application works as usual, then you don't have any cross-scripting problems. If there are any errors in the console or your application breaks because something gets blocked by the trusted types policy, then you know you have to make sure at this point to prevent cross-site scripting. And if you do it right, then you can just disable it for protection and you will be safe. Or there are also so-called polyfills, which kind of should make it work in browsers who don't support trusted types, but I didn't really check that out in detail. So take it with a grain of salt, and if you need it, check it out yourself. And here is a very nice write-up, which explains everything about trusted types in quite a good detail. Yeah, I think it's a really cool feature and it has a lot of potential, but it's still very new. And yeah, let's see if it can really change something. Okay, key messages. Number one, we talked about 3 different types of vulnerabilities that have been always a problem in the last 20 years till now. And so please, if you develop applications, make sure to really thoroughly take care of those problems or potential problems. For access control, make sure to always do it on the server side. Try to centralize it because it gets easier to manage it and be very strict. So no backdoors and deny by default. For crypto, mutual TLS is no longer a luxury. So it's just state of the art. Also for internal services. So please make use of it. And for the injections, always separate user input and code structure with appropriate frameworks, and check out trusted types. I think it's very nice, and I hope that it will get more popular in the future. Okay, thank you very much. Do you have any questions?
Thank you very much, Daniel. I'll just take a quick look also in this Zoom. Maybe there are some questions in the chat. There are actually. Okay. All right. No, it seems to work. I don't see any questions right now in the chat. Are there maybe questions here in the audience or something about specific topics? Is there something where you say, okay?
Yeah. During your presentation, it just came to me. Why do they keep changing the definitions for their OWASP categories?
Can you repeat our question, because maybe it's not loud enough for the.
Yeah, the question was why the OWASP sometimes renames specific categories, right? That was the question. Yeah. I actually don't know really. Sometimes they really try to find more appropriate names, or sometimes the nature of the vulnerability changes a little bit, and they try to include more. And yeah, most of the time they use a more generic name to include more different subtypes of the vulnerability, I think.
But is it only the names that keep changing, or are those categories defined? Phrase or
very often there are new categories, so they make evaluations. The procedure how they evaluated this also changed a lot during the last 20 years. In the last one, they really they mixed some kind of research with real evidence-based data and some expert opinions, and they mixed all of that together and created the 10 most relevant categories.
It would be interesting, right? If they keep the definition constant.
That would be, yeah, that's true. Yeah, because as we saw for the crypto failures, the names and also what really was contained in the category really changed over the years. Yeah.
For trusted types, did I get this correct? The browser doesn't offer you sanitizations. Rather, you have to tell the browser, yes, I sanitized this.
Exactly.
For a dangerous thing.
Exactly. It just recognizes, okay, there is a dangerous thing, and you try to just put some text in there, and then it says, oh, make sure to take care of it, and he will only accept it if you say, okay, I took care of it. It's not a trusted type. So the responsibility is still at your side, but the browser refuses to proceed without.
It's like there should just be an option to disable these dangerous things and all.
Yeah.
Now it's default, and if your browser will warn you if you access anything that is not HTTPS by default.
Yeah.
So
yeah,
like
as an
something where we break the backwards compatibility a little bit.
Maybe it would be worth it. Yeah, it's true. I think maybe, yeah, as long as it is an optional configuration, it would be okay, I think. Yeah, because of course you cannot enforce it because it would be too strict for some applications, maybe because they want to do some individual stuff which might be dangerous, but they are aware of it and handle it correctly. But as an optional configuration, yeah, I don't see any reason why this shouldn't be possible. There was a question in the back.
No, it was just a comment that I think you can define policies how you want your trusted types to be verified by default, and you can use some HTML5 sanitizer.
Exactly. It was like this here.
So you don't have to do it manually every time.
Yeah, exactly. You can define a default trusted types policy, And I think you could also just say, yeah, it's fine, and do nothing. Or just block it completely, or sanitize it, or something like that. And then you don't have to manually to manually treat every input. Yeah. And this is also quite nice for if you have a lot of third-party components, because maybe they also do something nasty, and this will block those also, because for the browser it makes no difference if it's a third-party component or your own code. He will just see a sync, an unsafe sync, and some input, and will block it. So
what is the third-party component also sets a default policy?
Then I don't know, but I think it should work. Oh, if it sets a default policy, that's a good question. I have no idea. Yeah.
Maybe we can find the answer collectively. We got a few security guys here.
No, I have no idea how this would work actually.
We got another.
We have to try it.
2 questions actually right now. Maybe we'll find an answer to that one later. What about XSS attacks against frameworks like WordPress? We talked about solutions with React and Angular.
Yeah, I actually haven't really researched the WordPress issues, and I also haven't worked with them for quite a few years, so I'm not really up to date for the WordPress protections. But something like trusted types, I think, should also work, and also content security policy.
I'm not quite sure. I think we have actually also a YouTube video which tackles a few WordPress issues. I'm not quite sure. At
cool.
least we had also some CVEs like a few years ago. There are always some, I think, with WordPress. But no, it would be actually maybe interesting. Maybe Patrick, I hope you hear me. If you have further questions, we can surely answer them as well. So we try, and I will ask also internally, maybe we'll find some answers then in that regard. Another question would be, how do you see attack surface management tools like Sniper or similar, or which role does automation play in your penetration testing, pen testing strategy? Here's the link to snipersecurity.com. Do you know Sniper?
No, I don't know it actually. So I cannot really give a good answer to that. I think automation in pen testing is a big thing. For myself, I stopped pen testing a few years ago, so I'm also not on cutting edge of pen testing right now, but a lot of my colleagues are at Condignum. And I know that they try to automate a lot of things for pen testing. And I think there are a lot of things which can be automated, but not everything, because pen testing is a lot of good findings in pen testing are not just technical vulnerabilities like trusted scripting or code injection, but also business flaws, business logic flaws, and more advanced stuff. And you will, or maybe not always, but for another couple of years, you will need a human being to check those things.
And what was also really cool is for a few months ago, we had Synopsys here, which is probably one of the biggest pen testing tool providers out there, with Black Duck, or also with what's it called? Coverity. Thank you. Static code analytics tool, which is, if you said, like one of the best out there, at least right now. And there was a big discussion also going on about how much automation is good, and how much should actually developers learn about software security and how to enhance that. And it was a big discussion actually about it. If you say, okay, it's good to have some kind of crutch to just lean on, and that you learn it step by step. Others say that you get too dependent on it and say, okay, the tool find everything anyway, so I don't need that. And others say, you have to learn actually and take more responsibility as a developer or as a IT security guy, whatever, to learn more there. But I think it's probably also important to, because we got too less people. I think most people who are here, also the people who are hearing that everybody has more offers concerning jobs or other possibilities than they could handle. So I think there are too less people out there to just say, okay, you have to learn it maybe to have some tools there is
Yeah.
probably important. But Gabriel, was the answer so far okay for you, or you can always ask more also, it's no problem. Okay, Gabriel says, yeah, thanks. Thanks for participating, Osman. Thanks for questions. Are there more questions here maybe, or something else? I think so far, so good. I see no more questions in the chat, so I would say thank you everybody for joining. Also,
Thank you very much.
As well also for joining us again.
Thanks for having me. It was
No,
great.
no, always, and also at the audience and also the guys online. Here, hi. Write us please if you want to hold a talk, or if you want to contribute, or if you have ideas, or if you have questions. We're always here. The talk will be online on YouTube, on our SBA research channel on YouTube. There are also all the other videos. Also, if you just want to learn more, Sec4Dev has also a YouTube channel with over, I think, 120 videos about security over the last 3 years.
Cool.
We have also some people from CCC and Black Hat who held a talk, so maybe there's something interesting for you. If you have questions, please come to us or talk with each other about security issues. And we have our next meetup on the 24th November, so join. Next time I will get a very, very huge pretzel with everything on it. So come on site. We'll have 2 talks next month. So I will send you a notification. So looking forward. And thanks again for coming.
Thank you.
Cool. Okay.